Good morning, everyone. So this talk will be about web security and some stuff that you should know before you start working on this area. So my name is Renato. I work as architecture and design for Bleep, that is a Paddy Power Betfair company. So mostly of my work is on gambling and betting industry. I used to be a pen tester for security companies. I like to research security and I like to work with technology. So I'm a geek like you and nothing else. This talk, first of all, I will explain what is a modern web app and what we should know, where they are living nowadays. The most known attacks like cross-site scripting, cross-site request forgery, injections, because everyone likes injections, so I will talk about template injections, server-side and headers injections. CSS, because people sometimes forget that CSS can be used for attack websites, and some mitigations and how to protect better from the attackers. So, web applications. A web application that what people teach us during our school's years is just something like you have a client, you have a server, you ask something, the server delivers to you, and that's it. So we have a concept. But we know that this concept is not just the real life right now. Modern web app, since we do the first request, we know that we will hit a firewall, a load balancer, a first service that will know where it should drive your request for underlying service. That underlying service, they will enrich your data and then they will deliver to you. So what we can see here, it's a bunch of layers and a bunch of new links that we should be aware. And modern means right now a huge mess of technology. So this is just a bunch of technologies that we know that they are right now in production and a lot more. So for clients, we need always to work with HTML, JS, CSS, Anglers for servers, Java, PHP, all that kind. CouchDB, Kafkas for queuing, and the most known service, Apache and Nginx. So we have a big picture. We have a pile of technology, and we need to understand how they are being interacted and what data is being exchanged between them for us from a security perspective to detect the weakness point. But where these apps are living? So these apps are living in browsers, and browsers is the thing that will render our HTML code and will run our JavaScript code and present us to us. So some facts about browsers before we continue. So we have Google Chrome. Okay. Google Chrome. So what we should know about this? So in the first years, it was they use a render engine that everyone knows what it is. It will take our HTML and will present it to you with some rules. They use WebKit in the old times, and right now they are using Blink since 2013. They try to push the web forward and give you always new features. So from a security perspective, this is a nice browser to look for, and is multi-platform. Firefox. We are devs. We like to use Firefox, of course. They use Gecko as a render engine, and is the most direct link that we have to Netscape from the 19th. It's a multi-platform browser too. Internet Explorer. So someone hates them, other loves them. So it used Trident and Microsoft HTML until IE 11. We can find this browser inside web apps like Google Talk with the DLL that we can use it for the render engine. And right now they are doing a huge change. They are going for the Edge that is present on Windows 10, and they have a main feature. Edge will not be backward compatible, so it will delete everything that is old features, and they are trying just to be the most possible accurate for the web standard right now. So we have Safari. It's more for the Mac OS stuff. It uses WebKit, and we can find in more applications like the webmail. And Opera, finally. So it was on the beginning, they used Presto as render engine. It was an in-house development. But right now they have a fork of the WebKit. They are using Blink since 2013, I think, and it's multi-platform. So now we know where our web apps are living, so we should see what we can do. So cross-site scripting. So everyone knows or probably should know what is a cross-site scripting and what is the best part of a cross-site scripting. So I will start from the impact. Cross-site scripting will lead you to executing code on the context of the web application. So we can try to get the session, we can try to read the personal data of the user, local storage, and so on. So it still is one of the main flaws in the web, no doubt about that. It will take advantage of the different browsers features, so that's the reason we should know about browsers first, then we can try to exploit them. And everything can be a source for cross-site scripting. Local storage, forms, emails, URLs, URIs, whatever. Most known, reflected XSS. So what it is, we send a request to the server with a payload, and that payload is reflected on the response. So this is the most known. Why? Because people use it for social engineering. People use it to send a link to a friend, and when the friend will click that link, it will do something. Hello world in JavaScript is always alert one, so probably we'll do an alert one. DOM. Stored, sorry. So stored XSS. So it's a little bit more hard. The main difference is that hacker can put the payload inside the web application. So when someone is normally navigating through the page, it can trigger that payload. So it's really bad. The most common example is on the comments from the blog sites. If someone managed to inject code there, when people is reading the blog and reaching the comments part, it will trigger the XSS because it's stored in the database from the server. Then we go for the DOM XSS. And DOM XSS, although the payload to trigger DOM XSS is similar to the reflected cross-site scripting, the response is never changed. The webmaster or whatever have no idea that is being attacked because the DOM XSS will just change the way the page behaves on the browser of that client and nothing else. So sometimes it's pretty difficult to catch, but it's possible. And nowadays, with our modern web apps and modern frameworks, it's the only way to take advantage of that because everything is escaped. So in Angular, just with DOM XSS, it's the only possibility that we have. Or, of course, stored if you do a lot of wrong things. But then we arrive to the cool stuff. So Mutation XSS, it was a term coined by Garates and Mario, two best researchers in the community in the web. And what they discover, so they take a feature, a nice feature, that is the inner HTML, that is a feature that we can use to manipulate directly the DOM tree, to put from a safe state to unsafe state. And what is this means? I have this simple example. It means that the browser is really nice for us, and we'll take this anchor /href/title. I close the anchor and I put mutation. And what the browser will do for me for free, without I didn't ask anything, so I know what you mean, Renato, so I will put you a space where you have a slash. I will complete your href attribute and your title attribute, and I will close the anchor for you. So as an attacker, this is really cool because I can just send a bunch of garbage to the browser and you will say, I know what you want to do, so I will do it for you. So thank God it exists in HTML. And it's really nice to try this. You have the inner HTML test band, that is that link, you should test it. Every single browser have their own implementation, so different mutations will occur in Internet Explorer, in Gecko, WebKit, Blink. You should try them all. And then we arrive to blind XSS. So what we are talking about, two key things on these kind of payloads, patience and hope. Because we don't know if the payload will hit something, if some time will be executed. So what we should do? We should do a polyglot. What is a polyglot? It's a different string that we do that will execute on different contexts. So I'm talking about script context, HTML context, CSS, and it's a valid in all is that context. We send that, and we set up a listener where we wait for a connection. And if we have time, patience, and we really believe that something will happen, probably it will happen. So the targets for this kind of attacks is clear, that is back office and admin tools. That is stuff that we don't see from the outside, but it exists and will treat our data. So mitigation, there is no straightforward approach for fixing XSS right now, but we can do a lot of stuff to prevent it. So I'm talking about validating all the inputs first. So classic example, if I want a name or a number, a telephone number, why should I accept letters and symbols on a telephone number? Why? Just be greedy and deny all that. And when I'm outputting the data, I should always have notions of the context where I'm working on. So these examples, I put everything in the Unicode versions of the string. So simple stuff like this special ho. So here, we can see that have a representation. And although looks like a normal string, we know that in the real, it's not a normal string. It's full of Unicodes. So we should always encode stuff, even in JavaScript. HTML, of course, HTML entities, it will put nicely visually the entity that we want, but then the browser will never execute what it has been written to him. And CSS, because people forget to escape CSS, and you have built-in functions that you can use. As an hardening strategy, no doubt, you should use the CSP header that I will talk further, but this is the most we can do right now. Crosssite request forgery, nice attack too. So main goal, do something on the user behalf without the user notice that. How can we do this? So we are taking advantage of a browser feature that is the persistent, because they forgot on the beginning how to make persistence on the internet. So what they created was cookies, and they said every single time that I will do HTTP request, I will send a cookie. So as an attacker, we can see a window of opportunity here. So if I start a request on the user behalf, you will send the authentication cookie. Because as everyone knows, when we enter on Facebook or Gmail, we are not always typing our password. We are logged in. So we have a cookie for that. For a nice attack, the user needs to be authenticated, of course. We should create a forged request, so via image, via form, whatever. And of course, the impact will be really different depending of what we are trying to doing. So on Facebook, if they are vulnerable to CSRF on a post, probably I will post a message in the wall of that user without him notice. Of course, they are not vulnerable, so it will not work. But that it would be the impact for Facebook. In other applications, another impacts. So we have a hello world example that is transferring money, and we can see the baseline example that this one, simple GET request, will transfer money from Maria to Bob. But then we want that Bob do a new request to Maria with a huge amount of money. So what I can do, since the Bob is logged in, I can just try to click on this link, and we'll perform this GET action. And seamless way, just putting as an image source that without him to notice, if he'll go to my blog, it will do this request. So pretty straightforward. And via post, because there are some clever guys that thought if I do this by post, it's impossible to exploit. So of course not. You just need to trick the user to visit the page and submit the form automatically. Vanilla form, jQuery, whatever, similar attacks. So what we can do right now? So we can create tokens and no-ons for a session or a request. We should change them after the session or the request, depends, and we should validate them. So if people create tokens but they don't validate, just don't bother to put that amount of garbage in your web page. Just be clever. If you use it, please validate it and generate on a safely form. So what this will prevent? The attacker have no idea what is this token. So even he can know how to force the request, the request will not hit the back office because it will not work. It will say, this is not the token that I generate for the user, so it will stop there. Single page apps, so modern world, so we don't have back office. And now what? Craft a special header, something that the attacker cannot know. If you derive something from the session, the attacker for sure don't know that, and you can use as a special header to validate in the service. And right now the future, I think the reality, because Chrome already supports this, same-site cookies, it's a new flag. You can set this for strict OLX, and the browser will do the protection for you. It's saying, I will just send the cookies if I'm the real on the same domain. So on Facebook, we'll send a session cookie if I'm navigating Facebook. If I'm navigating Renato.com and I do a request, it will say, I know that you are not on the same domain, so I will not send the cookies for you. So if this is the strict version. And let's go for server-side template injections. So I will talk about 3 injections in a row, template, servers, and headers. And all of them can do more than what it appears. So what is this kind of injections on the template side? People use templates for a dynamic app, and of course it's cool to use templates. But sometimes people forget what they are doing can be really, really dangerous, because templates are rendered on the server side and then sent to the client. And most of the times, people thought when they found this, they found XSS, but that's not the real case. So a practical example. So in this example, it was true in Flask that used Jinja2 as a template engine. And here, they ask for a name, and this clever guy just put the object.secret because he believes that exists that property of that object. And in the server side, we can see that the guy is taking the name, is checking in the server side what is the person secret, and then is doing the substitution on the hello part. So that's the reason in the page it will appear hello Ryan and the secret. So of course, this is the bad part, substitution, because person.name is putting the person in the name, and is taking directly from the get attribute without no validation. So it will be rendered here, and substituted here. So the fix was pretty clear. If I want the name of that person on my template engine, I just should put like this, and I have 100% sure that I will just take the name of that person from that object. So with this in mind, we go to the server side. This is more a classical bit of injection. So we are just injection again about code that is reaching our endpoints without being validated. So the problem is the attacker can do a lot of nasty stuff. In the worst case scenario, take over your server. So PHP, classic example. I want to delete a file from my uploads because the user doesn't like his avatar. So I just get the file name from the GET request and I pass to a exec. Completely wrong. You should really be careful with this. The payload is there. It's really simple, and it will try to delete everything that have permission, of course. And Node.js. So a lot of people are working in Node.js, and by some strange reason they are using eval for this kind of operations, and they really don't care. They are taking the request body without filter anything and just send to eval. So pretty clear here, this wasn't sanitized, and it's inside the eval. So if you know Node.js, you can just require process and blah blah child, and you can netcat, bash, whatever. You can have a reverse shell easily. You can create your own HTTP client with the leaves that you know. Whatever, do your best. So in JS world, stuff that we should know and sometimes people forget. So eval, don't use eval, please. Set interval and set timeout. Two normal functions, but everything that goes before the delay, it will be executed. So it's like an eval that people sometimes don't know. And the ECMAScript 2015 brought us some cool stuff. So now on the return we have the injection. If the injection goes to a return, it will be executed. Promises, it will be executed. And in the functions, the attribution for default parameters for a function, it will be executed. So you have a lot of more. There is a lot of papers going on with these kind of tricks. You should look at them. And then we are going for header injections, HTTP response splitting. I believe that Wednesday or Thursday, Node.js suffered from the same thing again. I really can't believe this, but it's true. So what is going on? The attacker managed to put on the request special characters that will manipulate the response from the server. This is in the short version. So what I'm talking about, carriage return and line feed. So /r/n, same thing as it enter. So classic example. This is not a vulnerable example. Why? I'm putting here the it enter, let's call this, and here two hit enters, that is for a new line in a space, and I'm trying to craft a new request. So what happened? In my location, I have all that content, so not vulnerable. Nothing will happen. Vulnerable example. So after the content length 0, I have new line, empty space, and I'm crafting. What you can see is here, I'm crafting a new response, and the browser will answer my new response. So please, please, sanitize this. Always try to catch these elements in all kind of forms. And that will lead me to the next slide. So really clever guy, file descriptor, thought, I will try this on Twitter, and he managed, of course, because he knows what he's doing. And what he discovered it was, he remembers from a Firefox bug that the encoding and the way he extracts encodings managed to do bad things. And what was the bad thing? He mutated the string. He discovered that Twitter is filtering /r/n directly, and is filtering all type of encodings of that two symbols. So what this guy discovered really clever is, I can try, because I remember that Firefox bug, that if I manage to find some symbols that ended like what I want to inject, probably if I'm encoding them, I will bypass the blacklist of Twitter, and probably, and just a probably because we don't know, I will be able to inject the final character that I want. And he was right, and that's the reason I'm saying this to you. So even if they are filtering everything related to /r and /n, you should always find, you have tons of these characters. I found this one was their example, file descriptor example, and you just should look as the termination. You encode it in UTF encoding, completely different from their blacklist because there is no 0D or 0A there, so you will bypass it, and then you can expect a bug. You should remember the bug exists because this is 2-byte characters and not just 1-byte characters. So sometimes when they are parsing, they will just go for the last part of the last byte. That is the part that we want to inject. So this is why it works like that. And CSS as a friend. So CSS, it's really cool, right? It's just the language for look and feel of a web page, and nothing can go wrong here. So a little bit of history. Firefox, our friends did crazy stuff with mouse binding, and they managed to let you add XBL files in the old times that have some bindings for the elements in HTML. And with this technique, we could inject some XSS. We could inject code. So it's not working anymore, so you forget it, don't try it. They tried to use it, but then some clever guys used the data URI technique to inject the data again, so they failed miserably, and they remove it from the browser, from the old times. Opera, O-Link. So it's unique for the Presto engine, so that's the reason why it just works in Opera. And in the old times, they let you use the pseudo-URI JavaScript as a link. So, of course, we could inject directly code on a CSS style, and we have what we want. And our friend, no doubt, Internet Explorer. We love Internet Explorer. And Dynamic properties. So these guys, they had expression, behaviors, HTML components, and scriptless in the old times. This is a simple example of an expression and how you could use the pseudo URI to load a background. It's not working anymore. We thought that. So, artifacts. CSS is being used for attacks for what? Defacement and phishing. So I'm talking about clickjacking stuff. You change the UI, the user doesn't notice and will do something. Data leakage via attribute selector. So this is completely working right now. You can just try to select that ID, that name. And with the function background URL, we can exfiltrate everything we want. It's more like a side channel. Session ownage, it just works in Firefox. It's Gecko specific. And why? Because they have a really nice property that is the Moz document that will read the URL. And we can apply regular expressions to what we are reading for, I don't know which reason they have this option, but maybe for the same CSS document behave on a different way on different URLs. So, but what Mario, a really clever guy, did, of course, it was if I can read the URL with CSS and I can apply a regular expression, I can brute force what is there. So in this POC, if you open in Firefox, it will side channel the session that is present on the get. So you should check your network tab for that. And Mutation XSS, of course. We saw what you can do with an anchor. Style is no different. We should try all kind of mutations with this, with CSS. And reality check. So Internet Explorer, because it's our best browser we have, they didn't want to let the users down. And why? So they continue the development of the web browsers, and they didn't want to kill all the old features because of backward compatibility. So they create something that is Compatibility View or Compat mode. And with this, we can, on the modern web browsers, activate old features. So we are thinking about maybe we will get expressions again. Maybe, let's see. So first of all, a few steps. If the doc mode, not the doc mode, the doc type is set for the latest one, Quirks mode will not work. Quirks mode is the mode that will enable to us activate the doc mode type. So it's two similar words but completely different. And if we can enable the Quirks mode that we will enable, we can try to use the doc modes. And doc modes will pass to the frames under him. So this is a really nice stuff. If I can iframe a page, if they are not setting doc types or doc mode specifically, I can tell that page to render the way I want. And of course, old features are back. So let's see. Expressions. So we thought we can use expressions, but Internet Explorer, they know, Microsoft, they are not dumb, and they know that it was a really, really bad idea at the time. So in IE 10, it was the last browser that supports expressions. We need to set up to doc mode 7 to use expressions. That is the compatibility mode for IE 6 and 7. But after IE 10, it's completely impossible to exploit this. But if you have users in IE 10, you can try it. It will work. Behaviors. So behaviors, first fact, they need to be on the same origin. That's a problem. They need to have specific MIME types. That's a huge problem to bypass. Okay, so but what we know, HTML component, .htc. So we can use this as doc mode 9, but again, this kind of component, this behavior, have a really specific MIME type. So even if we manage to inject the file on the same domain, we will not be able to recreate the MIME type that we want for execution. But then we have scriptlet, and scriptlet came to save the day, and I show you the attack. How can you do this? So this is just really the page that you need for the attacker. And you will set the compatible mode for IE 10, victim of an XSS, of course, you need an injection point, and for some reason you managed to have on the same domain a file. And for this run, you just need to have this file being served as text plain, HTML, whatever. So it's really easy to have the MIME type right. And this is the example of the scriptlet, so we can do whatever we want here, and we will have an XSS with style in a modern browser, i.e. 11, not Edge, because Edge killed everything that is compatibility. So just in IE 10, 11, sorry, and it's working nowadays. So this is some of the nicest attacks and the most easy stuff we can find around. But if you want to work in web security, of course you need to know a lot more related to web attacks. And I need to have a slide with that because people need to be aware. Injections, it doesn't stop like this. You have SQL injections, NoSQL injections, session fixations, XXC, and so on, crazy attacks like relative path override, server-side request forgery, so on. You should continue. If you want to know more about this, you should take these keywords and try to read a little bit more. Some of them are really easy to understand, others a little bit more complex. And with this, I'm going for more defense strategies. And what we can do, so we like open source, we have tons of code, and now what? So the main goal of the code review is to check if the security and my logical controls are there in the code, first of all. They are working, and they are present in every single spot that I want. So this is what the main goal of a code review from a security perspective, of course. And there is no magic. There is nothing I can say you that we will spot all the bugs in your code because you can read it. No, but we should always looking for the user interactions. So inputs, outputs, all the data that is being exchanged between the different layers that we saw before, because modern web apps are linking and connected to tons of service, so you should look for that. And if you are lost, just go for the juicy thing. Just go look for the upload function, register, log something, give me money. Maybe that is the function I want to check if it's vulnerable or not. And I really like checklists, so this is just an helper. You can use it or not. This is whatever. I do like this for me, data validation, input, output. Did I check everything on my source code about that? Yes. So authentication and authorization. Did I check if the user is authenticated to do this action and have the proper authorization? Yes, I did. So check. Session management. When I'm working with mobile and offline, this is a mess. It's completely crazy how we can handle this. Let me check if is everything doing as expected. Ciphers, logging, error handling. I have every exception worked out? Yes. And sometimes the hardening features, they are not present in the code, and people must know that we can do hardening on the server side. And I will give you a small, it's not tricks, just sets of features we can activate in server side and some of in the application layer for a better protection. And I'm going for HTTP headers. HTTP headers is simple. We use headers for everything in HTTP, but in this context, I will talk the headers from what the server sent to the browser, and the browser will happily do it for you. So let's start for the first header, XSS protection. Simple header. It tries to activate your XSS filters from the browsers. Every single browser except Firefox have XSS filter. What they are doing is, I will catch your URL and I know that's what you are doing, so I will try to stop you. One option, protection 1, it's activated 0, it's not activated mode block. If I detect something, the page will not open at all. But, sorry, as always, there is a dark side. And you should look, it's a nice research from a Japanese guy, I believe, where he used the IE filter again, IE filter, XSS filter to create an XSS on a page that was fully protected. So be careful with this header. And just for FYI, Facebook have disabled this header because there is a huge discussion around this. X-frame options. So we can see that framing is bad. Framing is not just for clickjacking. Framing is bad because we can get the doc modes from other page, And we can do really nasty stuff when we are talking about injections because we have a lot of new variables to use to inject on the framed page without length restriction or word restriction. So we should not let our application be framed. Same origin, Renato.com can frame Renato.com, deny no one can frame my page, and this domain allow from this domain and this domain can frame my page. X content type options. We saw before that we use the MIME type. And the browser have a nice thing that is when you don't declare the content type, I will try to infer what content type it is. So if I saw a HTML tag, probably it's an HTML page, so I will serve to the browser, I will tell to the browser, or the browser will take that page and render as HTML. So if I use this header, no sniff, I am saying the browser to don't do nothing and don't execute anything. So we can kill a lot of attacks with this, so you should use it. Strict transport layer, HTTPS generation. So we have tons of free CAs that we can use right now. And this header is saying to the browser, after the first connection, always, always, always use HTTPS to interact with me. I have, during this age, 1 year, and all my subdomains, please use just this connection. So every single man-in-the-middle attack will fail, because the browser, even when it's trying to connect, example, facebook.com, it will not connect because someone is trying to downgrade the connection. Preload is just a simple feature that is saying that I want to be preloaded on a special list that browsers have for fully connect HTTPS. Content security policy. So this is a really complex header. I will not explain here. There is a lot of talks around this. Simple. In short, this is a whitelist. I will say what I want to load inside my application. Image, scripts, everything you can remember, you can set there. It will help you mitigate the XSS, no doubt, but it's no bulletproof as always. And I have a simple link, the builder there. You can check the configurations from Twitter, Google, and you can try to understand what they are doing. Public key pins. So I can tell the browsers to always use HTTPS to talk to the server. So why not I cannot say to just talk with this specific certificate, please. So the pinning is just that. I will pin my application certificate in the browser, so the browser will only connect if this is valid, and if it's not, it will not open the connection. Again, man-in-the-middle protection, it will kill that kind of attacks. Upgrading secure request, although it belongs to the CSP header, it's a really nice thing to talk about because people have a lot of legacy code and sometimes they want to fully migrate to HTTPS to avoid mixed content. And with this simple meta tag that I think is available from CSP2, you can set it in meta tags. You are saying to the browser that every single connection that you detect in HTTP, please upgrade to HTTPS. So easily as a simple meta tag. Sub-resource integrity. Nice thing. The guys they wrote the spec some time ago, and their main goal was to kill XSS in CDNs and all kind of temperings of external scripts that we are putting in our page. So with this, it's not a header, it's just a attribute for this HTML element we can use for CSS scripts. We can just make sure that we are loading what we want. I check the integrity before, and the browser will do this for us. If the integrity is not a match, it will not load the content in my page, and we know that probably was tempered or changed. And of course, simple things, but people sometimes do mistakes. Session cookie. I want a session cookie, I don't set up an expiration date. Secure cookie, flag. Just go this cookie via HTTPS, secure channel. HTTP only goes through HTTP requests. JavaScript will not touch this. And same site cookie, as I explained before, for cross-site request forgery mitigation. So strict and lax. Strict if you really just want to send a cookie when people are navigating, and lax, it can allow you cross-origin, but just if I have on a link for Facebook on my page and the top domain goes for Facebook. Otherwise, it will not let. And post requests are completely down. The cookie will never go with the post request. And taking these bug bounties, so simple stuff. Can we practice in the wild web? Yes, we can. And where? So Bugcrawl, HackerOne, full of programs. Check for a security page. You have a tons of security page around. They will explain you the rules, how you can try to exploit them. And why people do this? People want to do this for reputation, for fun, for testing new skills. So the report is the most important part when we are participating on a bug bounty. And why? We should be clear when we are communicate something that is bad in their site, in their system. So this is my example that I use. You can use your own, of course, or you can just copy. It's the same thing. So when it was discovered, date and time, the domain in the system that has the bug, vulnerability type, just go, put the perfect vulnerability type in the description. You can just go to OWASP and another projects and try to get that information. Impact, this is what will give you money, for sure. If the impact is really nasty, you will have a lot of money. If the impact is just, nothing happened, you will not get anything. Although it's a bug, they will not give you anything. They will just give money just for impact. Proof of concept. Works in which browser? Which quirk mode are you using for working this kind of attack? Attack vector. How can I deliver this in the wild? Payload. What is really triggering the vulnerability? Image and video for easy. And mitigation if you have any idea how to mitigate. Don't send cross-site scripting is fixed doing HTML encoding. Don't send that if you are doing completely different attack. So just the note to finalize. Don't do bad things just because you can. Don't send a network down because you managed to put a network down. Don't beg for money, that's really bad. And remember that in the other side, there is always a security team that is not only working for a bug bounty program. So even if you submit today, don't expect to have in 1 hour an answer and the money and everything. Just be patient. And that's it. That's my presentation for today. I'm open for the Q&A. Thank you. So, any question around? I will be around if you have any strange question or more heavy question, but anything? I will not say that.
Hello. So you've mentioned, I don't remember the name of the flag that forces the browser to always use HTTPS. So a while ago there was some tricks that could be used to exploit that flag to create super cookies to track users between sites. How do you think that the browser should handle that? Should they ignore that flag and let security slip? Should they be more worried about user tracking? Should they give a warning?
So super cookies is a concept. It's not real life. It's not the cookie itself. Super cookie is just a concept that people create to track a user, even though I'm not using cookies. I'm using storage from Flash, storage from Silverlight if it still exists, whatever. And the question was if the user should be worried about tracking and?
Should the browser do something about it, or just say, well, this is good for security, I should not warn the user that this might be dangerous? I don't know.
You should remember that super cookies are using features, they are not using bugs. So if the browsers close all that features just because someone is using them for a super cookie, they are destroying the dev lives or what they intend on the first place. So there is no straightforward approach for sure for killing the super cookies right now. We can try to mitigate them when we're discovering a new way to do that, better way, but it will always exist a way to track a user.
Okay, thank you.
Anything else? No? So, okay, I will finish. Thank you for your time.